It's just a bit of a somewhat interesting cost-cutting measure that I found in a sharper image electronic piano that I'm fixing. Instead of just using a proper packaged microcontroller, they just have this cob assembly where it's a piece of FR4 or some kind of fiberglass. Might not be FR4 because that might cost too much. But yeah, it's Chinese electronics. But anyways, it's a piece of FR4 that has a cob on it for the actual main microcontroller. All crapped on IOs. Basically, that's all for the button matrixing in this thing. And then there's a similar cob assembly with a square cob, or rectangular cob, which I haven't really seen before, for the main program flash. It's quite interesting as a cost-cutting measure, given just how complicated this is, like having to have a worker butt solder all these joints, because that isn't really the kind of thing that you'd be easily able to do by a machine, I don't think. Well, there's some stuff like that. All those curve necking right there is a means of ground current control, which is reasonably good design. That goes down to that gold device there, which, judging by the pinout, that's going to be the main audio amplifier. Those two nuts are just for a stamped piece of aluminum as a heatsink for it. Because the principal reason for these investigations is because this thing claims 24 watts on the bottom, but it says 120 volts, 24 watts, and this thing doesn't have a built-in power supply. It takes an external 9 volt supply, and yeah, there's no way the internal construction of this thing can support 24 watts or anything close to it. So, yeah. That's just see, those are some of the busing for all the these flat flex cables, which go out, really cheap, nasty flat flexes too. But those just go out to all the boards, which are all this PCB, they're really nasty paper laminate PCB too, with rubber dome button matrices. So yeah, pretty cheap way of doing it. And then the switch, which was defective, it actually would only turn on if I were physically holding the switch in. So I just had to basically cut all the various traces, because the switch does some weird stuff with shorting out the supply rails when the thing's turned off. After the switch, of course, is my guess is as a means of keeping the thing from making all kinds of weird frumpy noises when the thing is powered down. And the capacitor is allowed to bleed out. So yeah, and of course, old dyeing masking tape, which is, I think this thing is 10 years old. Stuff may degrade that fast, but because this PCB has a April 13th, 2004 date code, and this device is week 9 of 2004, so it'd be March, and early March, and this flash, December 1st, 2003. And that's a design date. The PCB there is week 29 of 2004. So yeah, really cheap consumer electronics rubbish. Yeah. And then there's just the liquid crystal display with 4 wires, supply rails, 1 CLK, and I guess DA, so that'd be just a clock and data. Might even be I2C, even though that would typically be SCL and SDA, but that are just, 2-wire serial. So yeah, it's typical cheap and nasty consumer electronics. Hewley or Owley or whatever Lytics, even though they are 221 degrees Fahrenheit. That's just a 5 volt regulator for the microcontroller, and there's 2 things which are actually connectorized, but that's just because those are the 2 ribbons going off to the keyboard button matrix, although I need to clean up some switches in that as well. And there's just a bunch of 10,000 ohm resistors as pull-ups, all bent and grunched and all nasty. A lovely internal construction, he said in the most facetious and sarcastic manner. And also, one other thing is that on the solo screen you can see that these all have the I/O ports for the I/O pins for the microcontroller labeled. Somewhat interesting.